Hi, this is Mr. Mac. This is a concept video on verifying trigonometric identities and solving trigonometric equations. I think it will be the last one that I'll be subjecting you to this school year. Now, I'd like to start out on this one by talking about your Trig Identity Toolbox. Now, a little bit earlier, actually, I think the first section of chapter 14, there were some basic identities given in a concept block, and they were things like the tangent of theta is equal to the sine of theta over the cosine of theta. And let's see what else we had. Cosine squared of theta plus sine squared of theta equals 1. And then we had cosine of pi over 2 minus theta is equal to the sine of theta, and sine of pi over 2 minus theta is equal to cosine of theta. And we also had sine of the opposite of theta is equal to opposite, let me just do this again here. Sine of the opposite of theta is equal to the opposite of the sine of theta, because the sine is an odd function. Cosine of the opposite of theta is equal to the opposite of the cosine of theta. And tangent of the opposite of theta is equal to the opposite of the tan of theta. Now, there were a number of identities that kind of were spawned from these. First of all, let's just take a look at these. It's nice to know that if you have an xy axis with an angle theta here, and this is the value y, and this is the value x, and this is the value r, that sine of theta is equal to y over r, cosine of theta is equal to x over r, tan of theta is equal to y over x, cosecant theta is equal to r over y, secant theta is equal to r over x, and cotan theta is equal to x over y. Now, a lot of times when you're verifying trigonometric identities, that's one of the things we want to do, we have these identities kind of in our toolbox. Let me mention just a couple more. Because of the cosine squared plus sine squared is equal to 1, we get 1 minus, I can do this, 1 minus sine squared theta is equal to cosine squared theta, and 1 minus cosine squared theta is equal to sine squared theta. So we can make that substitution if we want. Now also, if we divide this Pythagorean identity by the cosine squared of theta, we get 1 plus tan squared theta equals secant squared theta. And if we divide the Pythagorean identity by sine squared theta, we get cotan squared theta is plus 1 is equal to cosecant squared theta. And then, of course, also, if you wanted to take this identity right here, 1 plus tan squared equals secant squared, and subtract 1 from both sides, you get tan squared theta is equal to secant squared theta minus 1. In other words, there are a lot of identities that come from these. But it would be a good idea to think of this as your basic toolbox of trig identities and to know these at least. Now, what do we mean, or what are we talking about when we say we want to verify trig identities? Well, here is a trigonometric identity, for example. 1 plus cosine theta times secant theta minus 1, all divided by the cosine of theta, is equal to the tan squared of theta. Now, to verify this identity, what we are going to do is we're going to start with one side or the other side of this identity and transform that side through saying this is equal to that, this is equal to that, making substitutions until we end up getting the other side of the identity. Now, it always makes sense to start with the more complicated side. So in this particular case, the 1 plus cosine theta times secant theta minus 1 over cosine theta is much more complicated than the tan squared of theta. So we're going to start with that particular side. And we're going to write steps that say, well, that's equal to this, and then this is equal to that. And we'll get what is called a hypothetical syllogism. If A, then B, if B, then C, if C, then D, if D, then E, and once eventually E will be what we have on the other side, if this really is an identity. Okay, now a technique that seems to work well is to rewrite when you've got an identity like this, and notice I've got cosines and I've got secants on the left-hand side of this identity. And so it would be a good idea if we could rewrite all of these things in terms of just sines and cosines, or in this case, probably just in terms of cosines. Because the first factor in the numerator is 1 plus cosine theta. Now, one of the identities in our toolbox is that the secant of theta is the reciprocal of the cosine. So we can write the secant of theta as 1 over the cosine of theta minus 1, and this is all over the cosine of theta. Now, the next thing it might occur to us to do is that if we want to add or subtract this 1 from this 1 over cosine theta, this 1 has to become a fraction that has cosine of theta as its denominator. And so that's pretty easy to do. We get 1 plus cosine theta for this first part times 1 over cosine theta minus, now if we want 1 to be a fraction with the denominator of cosine of theta, then it's obviously cosine of theta over cosine of theta. And this is still all over the cosine of theta. Now, let's think of this cosine of theta in the denominator as cosine of theta over 1. And so what I'm going to do is I'm going to, instead of divide by the fraction cosine theta over 1, I'm going to multiply by the fraction 1 over the cosine of theta here. Now, a little bit more that we can do here is we can write the first term, 1 plus cosine theta. Now this second one becomes 1 minus cosine theta all over the cosine of theta. And then we're multiplying by 1 over the cosine of theta. Now, if we thought about this one, we could think of this as 1 plus cosine theta over 1. And so now we have three fractions that we're multiplying together. So we're going to be multiplying 1 plus cosine theta times 1 minus cosine theta times 1 for the numerator. And the denominator is going to become cosine theta times cosine theta. Now, let me point out here also that knowledge of algebra and factoring is many times going to be really useful here. Think of this as A plus B, where A is 1 and B is the cosine of theta. And think of this as A minus B. When you multiply A plus B by A minus B, you get A squared minus B squared. So when we multiply those two together, we're going to get 1 squared minus cosine squared theta times 1, of course. And in the denominator, we're going to have cosine squared theta. Now, one of the identities in our basic trig toolbox is that 1 minus cosine squared theta is sine squared theta. So we can write this as sine squared theta over the cosine squared theta. Now also notice that the sine squared theta over the cosine squared theta is the same thing as the sine of theta over the cosine theta all squared. That's a property of exponents. But the sine of theta over the cosine of theta is the tangent of theta. And if we're squaring that, we get the tangent squared of theta. So what we've done now is we have taken the left-hand side of this identity, 1 plus cosine theta times secant theta minus 1 all over cosine theta, and transformed it through reasoned steps till we get the tangent squared of theta. And what that means is we've verified this identity. Now, Ordinarily, when you're verifying a trigonometric identity, you're only allowed to work with one side. You can, sometimes they allow you to work with both sides, but if you're working with both sides, you're just transforming that side. You are not adding the same thing to both sides or subtracting the same thing from both sides. That's not allowed. So most of the times your trigonometry teacher, when you get there, will say, okay, verify this identity, choose one side or the other, but don't work on both sides. And so there's an identity. Let's work on another one. I'd like to show you an identity that is one of my very favorite identities. Yes, I am a real nerd because I have favorite trig identities. This one is the secant squared of theta plus the cosecant squared of theta is equal to the secant squared of theta times the cosecant squared of theta. Now, when I first saw this, I thought, well, that's so cool. No matter what theta is, if you square the secant and cosecant and add them together, you get the same thing that you get when you square them and then multiply them together. So this is an identity that when I first saw it, I thought that was just really so cool. So let's verify this one. Now, the way I've written it, let's just go ahead and use the left-hand side, and we'll start with the left-hand side, see if we can't get it to look like the right-hand side. So on the left-hand side, the secant squared of theta is really 1 over the cosine squared of theta. And the cosecant squared of theta is 1 over the sine squared of theta. That's because the secant is the reciprocal of the cosine, and the cosecant is the reciprocal of the sine. Now, if I want to add these two fractions together, I have to have the same denominators. And the lowest common denominator in this case would be sine squared theta, cosine squared theta. So this fraction has to be multiplied by sine squared theta over sine squared theta. And this fraction has to be multiplied by cosine squared theta over cosine squared theta. Now what that gives me is the sine squared of theta plus the cosine squared of theta all over the sine squared of theta times the cosine squared of theta. Now, in our trigonometric identity toolbox, we know that the sine squared of theta plus the cosine squared of theta is 1. So I'm going to replace sine squared theta plus cosine squared theta with 1. So we get 1 over the sine squared of theta times the cosine squared of theta. Now, since we're multiplying in the denominator here, we could write this as 1 over the sine squared of, no, actually, let's do this. 1 over the cosine squared of theta times 1 over the sine squared of theta. Because when you multiply the fraction 1 over the sine squared of theta times 1 over the cosine squared of theta, you'll get 1 over sine squared theta cosine squared theta. But 1 over the cosine squared of theta is the secant squared of theta. And 1 over the sine squared of theta is the cosecant squared of theta. And that's what we wanted to originally show. So we verified that the secant squared of theta plus the cosecant squared of theta is equal to the secant squared of theta times the cosecant squared of theta. A really cool identity. Now, you'll get a chance to do some of that in the exercises in Chapter 14, Section 2, and you'll certainly get a chance to do a lot of that next year in either pre-calculus or trigonometry. Now, the other thing that's covered in this particular section is solving trigonometric equations. Now, sometimes some ability with trig identities is important because some trigonometric equations need to be transformed before you can actually solve them. But let's start out with a fairly easy equation here. Let's say we have the equation 2 cosine squared of theta minus 1 equals 0. And we want to solve this, and let's just say solve for 0 is less than or equal to x is less than or equal to pi. We'll be doing this in we'll be doing this in radians. So what we're saying here is we want all the values in the first and second quadrant where this works. Now, the unknown in this particular case is cosine of theta. Notice, or actually maybe it's theta, but notice that the cosine of theta is our fundamental unit that we're going to be working with, because we're squaring the cosine of theta, multiplying by 2, and then subtracting 1. So to solve this equation, what we would do is we would undo what's being done to the cosine of theta. So first of all, I would add 1 to both sides. I get 2 cosine squared theta equals 1. Oh, by the way, I did add 1 to both sides of this equation. But you see, I'm not trying to verify an identity now. I'm solving an equation. So we're back in equation solving rules rather than proving an identity rules. The next thing I would do is I would divide both sides by 2. So I get cosine squared of theta is equal to 1/2. Now what I want to do is take the square root of both sides. So the square root of cosine squared of theta is cosine of theta. And on the other side, I have to introduce a plus or minus sign, and I get the square root of 1 over the square root of 2. So cosine of theta is equal to plus or minus 1 over the square root of 2. Now we would rationalize that by multiplying root 2 over root 2. And so we get plus or minus square root of 2 over 2. Now, if you think back to your unit circle, in the first 180 degrees, or pi radians, we had an x value at pi over 4 radians of square root of 2 over 2. And the y value is also that. And then at 3 pi over 4, we had the x value of negative square root of 2 over 2. And the y value was square root of 2 over 2. But what we want here is cosine of theta. Remember, the x is in the unit circle where the cosine of theta. So we can now say that between 0 and pi, theta is equal to pi over 4 or 3 pi over 4. And that's a trigonometric equation that we have solved. Now let's take a look at something that gets a little bit more complicated. So what if we have the equation 4 sine squared theta cosine theta minus 2 sine squared theta minus 2 cosine theta plus 1 equals 0. Now, this equation really does look pretty complicated, but I'm kind of hoping that you can see that there are 4 terms here, and the thing is set equal to 0. So if there were some way we could factor this expression, since it's equal to 0, we could set each of the factors equal to 0. Now this is a fundamental concept and skill or technique that you've learned in Algebra 1 and we've hopefully reinforced in Algebra 2. So we look at this and there are 4 terms, so it's not a special product. There aren't any common factors because one of the terms is just 1. So we're down actually at the 4th one in our factoring checklist of grouping. And if we want to group, say, the first 2 and the last 2, then we've got to make this a plus sign here and put a negative sign on the 2 cosine theta. Now let's group these 2 and these 2 and see what happens. In the first one, in the first group, you should be able to see that there's a 2 sine squared theta that's common to both terms. And we're left with 2 cosine theta minus 1. Now in the second group, I taught you inside, if right inside the parentheses there was a negative sign, that we needed to pull a negative common factor out. And there doesn't seem to be any other common factor, so we're just going to pull out a negative 1. So we have negative 1 times positive 2 cosine theta minus 1, because negative 1 times a negative 1 is plus 1. This is still all equal to 0. And let's just Put our hand off here to the side in case we need it again. So now notice we have 2 cosine theta minus 1 that's a common factor to both terms. So we get 2 cosine theta minus 1 times 2 sine squared theta minus 1 equals 0. Now that gives us 2 cosine theta minus 1 minus equals 0, or 2 sine squared theta minus 1 equals 0. Now this first one, solving this equation, we get 2 cosine theta equals 1. Divide by 2, we get cosine theta equals 1/2. Now that means theta is equal to, what is it, pi over 3, or 5 pi over 3 if we look at the unit circle. Now you can look at the circle, unit circle, and see that those would be the 2 radian measures that would give you an x coordinate on the unit circle of 1/2. And then we've got or. Now this one is really an awful lot like the first one I did. We'll add 1 to both sides. We get 2 sine squared theta equals 1. Sine squared theta equals 1/2. Sine theta equals plus or minus 1 over the square root of 2, which becomes plus or minus square root 2 over 2. So the sine of theta is square root 2 over 2 when theta is equal to pi over 4, or 3 pi over 4. And then it's equal to negative square root of 2 over 2 when theta is equal to 5 pi over 4, or 7 pi over 4. Now, since these two solution sets are connected with the word or, the entire solution set would be theta is an element of the set pi over 4, pi over 3, 5 pi over 4, 5 pi over 3, 7 pi over 4. I don't think I left any out, did I? Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oops, I skipped one. Which one am I missing? 3 pi over 4. That one goes right in here, 3 pi over 4. Okay, so theta is pi over 4, pi over 3, 3 pi over 4, 5 pi over 4, 5 pi over 3, 7 pi over 4. Those would be all of the values in the first revolution of the unit circle. Now, that's the kind of thing that you're going to be doing in trigonometry and verifying identities and solving trigonometric equations. This really just scratches the surface. There's an awful lot of different experiences in store for you. Kind of excited for you because this is really pretty cool stuff. But I'm going to end the video here. It's been a pleasure teaching you this year. Bye-bye.